This video is looking at the third reason for electrolysis, producing chemicals. This is the second one of these. It's looking at molten salts as an electrolyte when there's no water present. So the salts have been melted, so they've been turned into a liquid. We're looking at producing sodium, magnesium and aluminium metals. So these are molten electrolytes. The first one is producing sodium metal, which we've used in the lab before. The reason that we don't have any water with these ones is because if water's present, then water is a stronger oxidizing agent than all of these oxidizing agents. So water would undergo reduction rather than any of these metal ions, and so you would never get to produce these metals if there's any water present. So you can't have water, but you do need to have your electrolyte ions moving, so you have to melt them. So it has to be a liquid. So the states in this are really important. Normally you get used to just, as soon as you see that, you go AQ. You can't do AQ. It's better to leave these off and write nothing than it is to write an AQ. If you write AQ, it's definitely wrong. So they're liquid, they're melted. To do that, to melt a salt so that the ions are moving, you need to put a lot of energy into it. So it's normally electricity is put in to add the electrons, and you also need to use the electricity would be used to heat it and melt it. So to produce all of those metals, sodium, aluminium, anything below the water, takes a lot of energy, and the way we produce electricity in Australia, it produces a lot of carbon dioxide. So they're very bad chemicals to produce. Alright, so this is a down cell representation. It's producing a sodium metal and also chlorine gas. And this is not in water, it's melted sodium ions and chloride ions. So you should be able to look at these and identify where the anode is. So you can see this has got a positive on it here, and that's got a negative. So you need to know which one's positive, which one's negative. So which one is the anode? So the anode is the positive for electrolysis. So the electrons are coming from here, oxidation is happening here. So oxidation is happening, so chlorine gas is being produced here. So the electrons are coming from here, going around through the power supply and into the cathode, which this is cut in half, runs all the way around in a big circle, and the electrons are given to the sodium metal on the outside here. So the cathode. Okay. The sodium that's produced is lighter than the liquid sodium chloride, so it will float to this top and can be collected from the top. So what was the polarity for the anode? It's positive. Okay, there's also this ion shield here between the anode and the cathode. So the reason that we have this ion shield is to prevent the sodium metal that's been produced on the outside coming in contact with the chlorine that's being produced on the inside, because then you would get a spontaneous reaction with the products. Okay, this is in your textbook, I think. Same sort of thing, just different type of drawing. So the carbon anode, where the electrons coming from, cathode. So we've got this screen, this extra screen to prevent it, and it's made of iron. So prevent the chlorine reacting with the sodium, it's made of iron. Would the chlorine react with the iron? If you look on the electrochemical series, you can see that chlorine is a very strong oxidizing agent, and iron is a strong reducing agent. So they're in that negative gradient, so that they would spontaneously react. So the chlorine would convert back to the chlorine ions, and then it wouldn't react with the sodium. So eventually this ion mesh would erode. Alright, this is 2014 exam, one of the questions. So if you have a little look, pause the video. What metal is being produced here? What's the electrolyte? Okay, so you can see that it's molten magnesium chloride. Magnesium is similar to the sodium. It floats on the liquid magnesium chloride. The anode is in the middle again, and chlorine gas is again produced, and then the electrons go from here to the cathode, and magnesium is produced out here and floats on the top. So the question's asking, why is an inert gas, a non-reactive gas, blown across the top of the magnesium? So magnesium and all of those metals, sodium, aluminium, all of the metals that are under the water, are very strong reducing agents, and they will react vigorously with oxygen in the air. This question actually stated that in the information that was given. So an inert gas is blown across so that magnesium doesn't come in contact with any oxygen from the air, and otherwise it would react with it. So after these two videos, what are the two types of electrolytes used for electrolysis? Aqueous and molten. Alright, this is production of aluminium, another of the metals that's underneath the stronger reducing agent under the water. We have lots of bauxite, the rock that aluminium, the salt that it's in Australia. So we have bauxite mines all over Australia, and we produce aluminium. A lot of it is aluminium oxide, and it has a really high melting temperature, so you need a lot of energy to melt it. So they grind it up and mix it with sodium aluminium fluoride, cryolite, and that mix, it has a lower melting temperature, so it makes the whole thing have a lower melting temperature. To make the aluminium, because it's aluminium oxide, the oxide doesn't want to lose its electrons as readily as the chlorine does, so they use carbon anodes. Quite often carbon is inert, but in this case the combination of the carbon with the oxygen ions, that combination will lose its electrons and form carbon dioxide. So why did the carbon anodes have to be replaced fairly regularly? It's because they're eroding, because they're actually reacting, and they're making carbon dioxide. So use of aluminium metal is especially bad for climate change. Us producing aluminium metal is very controversial. Why does the production of this metal produce more carbon dioxide than any of the other metals? And there's three reasons. So producing aluminium oxide is below, so one of the reducing agents are metal that's below the water on the electrochemical series. So it actually uses a lot of energy because it has a high melting temperature, to make it a liquid. Then you need a lot of energy to give the electrons to it to undergo electrolysis. And then it makes, and so both of these in Australia, both of these producing electricity, we make carbon dioxide for both of those reasons. And then the actual anodes themselves also turn into carbon dioxide. So there's about 2.6 tonnes of greenhouse gases produced for every tonne of aluminium metal. Alright, review. These chemicals are not found in nature, sodium, magnesium, aluminium, because they're so reactive. So the reason when they were discovered was when electrolysis, the process, was discovered. So these must be molten. No water can be present, otherwise the water will reduce instead. And producing these metals is really expensive in terms of energy and the amount of carbon dioxide. So once you make these, you have to be careful of the products. You have to keep them separate from each other and also separate from things like water.